The crosshead on a slow-speed two-stroke is a difficult bearing to lubricate effectively. The load is continually downward, and because the con rod swings about the pin, changing direction each stroke, true hydrodynamic lubrication cannot take place. Instead, the lubrication starts as boundary, and as the rubbing speed increases, a hydrodynamic film is built up. As the rubbing speed decreases, the lubrication becomes boundary once again. MAN B&W type. The lower half of the bearing housing is formed by the top end of the connecting rod. It supports the crosshead pin over its entire length, the piston rod being bolted to the top half of the crosshead pin through a cutout in the bearing top half. Oil supply to the crosshead is via a telescopic pipe from the main LO supplier to pressure of about 2.5 bar. The lower bearing shell, tin aluminium with overlay, has oil grooves with machined wedges. The oil enters via the cutout channel in the center. The grooves extend right to the edges of the bearing to ensure a flow of oil, thus cooling the bearing. Sulzer RTA type. The early RTA had a forked crosshead with the piston rod passing through a hole in the crosshead pin and secured underneath with a nut. Oil entered the bearing through holes in the shell, via a groove machined in the lower bearing housing. The modern RTA has a continuous lower bearing, the housing formed by the top of the con rod. Only a lower bearing shell is fitted, the top bearing housing being lined with white metal. Oil boosted in pressure to 10 to 12 bar is supplied via a swinging arm. The swinging arm also carries oil at system pressure, 4 bar, for piston cooling. Tags.